According to the standard laws of thermodynamics, cooling is a strict linear process. An object has to gradually lose heat until its temperature hits zero. Think of it like a marathon. If water A starts at 80 degrees Celsius and water B starts at 20 degrees, they're starting at completely different points on the track. By pure logic, the 80-degree water has to spend time shedding its excess heat just to hit the 20-degree mark. Only then can it even begin the final sprint to zero alongside the initially cold water. But if you actually run this race, the hot water turns into an absolute cheat. It rapidly bypasses that entire cooling phase and locks into solid ice long before the cold water. This glitch in our physical reality is called the Mpemba Effect, and the scientific community didn't discover it in a multi-million-dollar lab. It was found by a teenager who simply refused to listen when his teachers told him he was wrong. The year was 1963, and young Erasto Mpemba was a middle schooler in Tanzania sitting through a routine cooking class. The assignment that day was to make ice cream. The standard recipe required boiling milk and sugar, letting it cool to room temperature, and then placing it in the freezer. But Mpemba saw his classmates quickly filling up the limited freezer space. Realizing he'd lose his spot waiting, he shoved his boiling hot mixture directly into the icebox. When the teacher finally checked on the class's work, the pre-cooled mixtures from the other students were still totally liquid. Mpemba's boiling mixture had frozen rock solid. He brought this up to his teacher, who laughed right in his face. He told Mpemba he was making up his own confused version of physics. Mpemba didn't back down. When a university physics professor visited the school sometime later, Mpemba challenged him to test it. The professor ran a strictly controlled experiment, and then the impossible happened. He got the exact same result. That single, stubborn refusal to accept an authority figure's mockery forced the world's brightest physicists to acknowledge a paradox they had entirely overlooked. You don't have to take Mpemba's word for it, though. You can test this physical glitch in your own kitchen right now. You'll need 2 freezer-safe containers, a standard kitchen thermometer, some measuring cups, and tap water. Because you are dealing with violently boiling water in this experiment, carefully use oven mitts and pour the liquid very slowly, and make absolutely certain that you are using borosilicate glass so your containers do not shatter from the thermal shock. Pour exactly 1 cup of 80 degrees Celsius water into container A. Pour 1 cup of 20 degree water into container B. Put both into the freezer at the exact same time. While you wait for those to freeze, let's look at one of the first major theories scientists used to explain away this math-breaking behavior, the evaporation shortcut. This chart compares the volume of both liquids over time. As the boiling water sits in the freezer, it rapidly releases steam. That vapor loss physically reduces the total mass of the liquid left behind in the container. Because there is literally a smaller amount of water left in the hot container, it requires less total energy to freeze, crossing the finish line first. By shedding its own weight as steam, the hot water essentially uses a mechanical cheat code to skip the back half of the thermodynamic marathon. That evaporation theory sounds perfectly neat and tidy, but there's a problem. It's incomplete. Even when scientists completely seal the containers, so absolutely no vapor can escape, the hot water still freezes faster. That failure forced researchers to hunt for more complex explanations. Some point to rapid internal convection currents swirling inside the hot liquid, while others argue that heating the water physically stretches and snaps its microscopic hydrogen bonds. Half a century after that cooking class, elite physicists are still throwing entirely different theories at the wall, fiercely debating what exactly causes this anomaly. Science isn't an immovable set of rules printed in a textbook. It's a continuous, messy process of observation. And sometimes it takes a stubborn teenager refusing to let dogma override his own eyes to keep that